Okay, so number 32 asks you to find the area of the region between this parametric curve and the y-axis. And in order to do this, you have to know what the graph looks like. And to figure out what it looks like, you can use your graphing calculator. And if you don't remember how to put parametrics into your graphing calculator, be sure to ask me at some point soon. And otherwise, you can go use some technology online, either Desmos.com or Wolfram Alpha, either one of those. But you can also think about what has to be true. Looking at the y part of the function here, t is inside the square root, so t has to be greater than 0. Looking at the x part here, you can think a little bit about the graph of this. If I were to graph this and just kind of put, let's see, x on this axis and t here, this graph's going to look like this. So what's going to happen is x is going to be negative during this time frame, which is from t equals 0 to t equals 2, and then after t equals 2 it's going to be positive. So if you put this together and thinking about y increasing constantly as t increases, the graph is going to have to look like this. And if you look here, you can see that y is increasing the entire time. This is t equals 0. T equals 0, it's going to be at the coordinate 0, 0. And as t increases, y is going to increase, but until t equals 2, x is negative. And then after t equals 2, x is going to become positive, and y is just going to continue increasing. But our mission is to find this area right here. And if this were a non-parametric curve, the way I'd want to do it is I'd want to think about sideways rectangles and along here, and that would be an integral that would be something along the lines of the height, which would be some x value, times the height of the length of the rectangle, times a little dy as a height. So it's the sum of x dy. And that's what we're going to have to want to do here. So we're going to convert our parametric and put it into this form right here. So let's do that. Okay, let me shrink this down, move this over here, and think about one of these rectangles right here. The length here, from here to here, is going to be, well, the big X value, which is 0, minus the little x value, which is this right here. So 0 minus that is going to be negative t squared plus 2t. So there is the x value. There is the x value times dy. And what is dy? Well, we know that y equals the square root of t. So therefore, dy is equal to 1/2 t to the negative 1/2 dt. And so then we have to multiply by 1/2 t to the negative 1/2 dt. And then we want to integrate this. Well, with respect to y, we'd be going from 0 to the square root of 2, because this is at t equals 2. And at t equals 2, y is the square root of 2. But with respect to, if we're integrating with respect to t, this is at t equals 0, and this up here is at t equals 2. So we'll just go from 0 to 2. And if we simplify this, we get magically, which then integrates. If we just anti-differentiate this, we get this once we've anti-differentiated, and if we evaluate this from 0 to 2, we'll get negative 1/2 times 2 to the 5/2 plus 2/3 times 2 to the 3/2. And then we subtract when we evaluate it at 0, but at 0 it is 0. So there is our answer in all its messy glory. Not a pretty answer. We could try to simplify this by putting some roots in there, but there's no real need to do that. There's the answer.